Hi, everybody. Thank you for coming to the conference. I hope you're learning a lot and getting a lot out of it. A lot of thought and effort went into it, so I hope it's getting everybody what they want from it. The first topic I think I really want to cover is, how grateful I am to actually be working in an industry that has such a significant problem to solve. And I'm going to go into that in a minute, but I think the enormity of what blockchains and smart contracts can really do for society is something that I think it's important for all of us in this industry and in our community to generally understand and have a very clear picture of. Because in many cases, I think it's larger than some people assume. And I'm also kind of amazed that we're at a time in history where we can actually work on solving that problem. And so the problem that we're solving and the importance of solving it, I think, is something we should keep in mind as we spend, such significant amounts of time and late nights working towards making this industry how the world really works. So the nature of what I think we're all doing here is we're solving the problem of what is the truth and how does society work on the basis of trust. And while those are very vague notions, I hope to make them a little bit clearer in this presentation, and then to show some of the steps that we've taken and are continuing to take to solve for these immensely important kind of problems and issues and improvements that can be made to society. So really what you see here is a spectrum. You see a spectrum where on the one side of it, you have what I call just trust us paper promises. And throughout history, this has been much of the way that society functions. You've basically had banks, institutions, insurance companies, Ponzi schemes, and various other kind of conglomerations of promises and ideas provide promises on paper that there was no really firm commitment, no real reason other than a choice or desire to fulfill. And everybody is so used to the world working this way that it isn't really something people question, and it isn't really something people believe they have an alternative to. The fascinating thing is that they do have an alternative, and that alternative appeared in 2009 with Bitcoin and has since then evolved into more and more advanced versions of what we call cryptographic truth. So cryptographic truth is the ability to guarantee outcomes based on cryptography and physics and encryption and math, basically. So on one end of the spectrum, you have some kind of paper document and some people somewhere that say they might do something and you hope that they do it. And then on the other side of the spectrum, you have cryptographic truth, which is enforced by encryption and mathematics, and at the most base level, really physics. And it's that cryptographic truth that Bitcoin and decentralized infrastructure and Ethereum and smart contracts and DeFi is just a progressively more advanced version of. So this is the spectrum that I think society and really the world kind of exists on. And the right side of the spectrum just recently appeared. And in the scope of history, it's just appeared just like a second ago, basically. And we have the kind of really, I think, the immense privilege to be able to drive this technology forward to change the way society works. So what do I really mean by that? So if we look at this in a historical context, we see that since the invention of these paper promises in the form of banknotes in the 11th and 12th century in China, you had a number of different banknote schemes that were all, recycled or deprecated or no longer used because they led to massive inflation. They led to overprinting. They led to defaults. And, it went from the Jiaozi banknote scheme to the Houzi banknote scheme, all of which had similar inflation issues. And, banknotes were bought to the West by Marco Polo and other similar traders. And then eventually they made their way into Europe with the appearance of Stockholm Banco, which created the first banknotes in Europe. In a number of years, those banknotes were also overprinted, causing massive inflation and a default in only a few years. So not decades, but only a few years. You had the first banknotes in Europe from Stockholm Banco, leading to overprinting and a default. And despite that lesson, and really because there was no other way to generate agreements and to generate money and to generate all of these kind of relationships that people need to generate in society, the Bank of England, had their charter signed in 1694 and generated the Bank of England banknotes, which then kicked off a long set of events, a number of failures, a number of overprinting, inflation, and various other dynamics, which eventually led to the Great Depression of the late 1920s, early 1930s, which was only stemmed by certain very extreme policies, such as the FDIC, which allowed the government to actually bank back deposits up to a certain number. I think the number is something like $250,000 per deposit. And this has been the longer term history of these paper promises and where they originated. And it's been a very long history, and it's filled with basically the same story, right? The same story is, what a great idea that we can generate paper promises. Isn't that wonderful? Let's see how far this goes. Let's accelerate. Let's really accelerate. Oh, it's kind of going well. Let's really push the gas pedal down. Let's generate a massive amount of these things. Oh no, we overdid it. Inflation, defaults, paper promises no longer being honored. We can't honor the paper promises because, we pushed the gas pedal a little too hard and we did a little too much, and we don't actually have the collateral to honor what we said we were going to honor. And so, tough luck. That's the world of paper promises. And everybody has been living in the world of paper promises for so long that is the way the world is. That's just the world. And what I'm here to tell you, and what our industry is here to tell you, is that doesn't need to be the way the world works. The world can now work in a much better way. And that's the fascinating, amazing thing about this, is that the world can work differently. What are we doing in modern times? In modern times, I can't say we've necessarily learned from the lessons of history. In modern times, we are, in the timeline of history, modern times from the 1930s or the 1970s, it's not like a second, it's like a second and a half, right? So it's a blip, it's a very small blip. But in that blip, we're pretty much at the stage of, let's just push that gas pedal all the way down and see how far things take us. Throughout history, when that gas pedal has been pushed down, generally speaking, it's always led to the same place, just a recurring pattern of history that invariably leads to the same place. Now this suggests to me that in the cycle of just trust us, boom and bust, there's a boom. There's now still a boom. Everybody is, printing money. Everybody is generating credit and debt. There was a separation from the dollar and gold right after it became the global reserve currency, thanks to Bretton Woods. And the reality of this is that has to have a problem at some point. And everybody agrees with that. And already we're seeing inflation increase. Now, I think people don't fully maybe see the magnitude of how far that pedal has been pushed. It's been pushed pretty far. If you look at the graph here at the bottom from Fred, basically the point at which the US went off the gold standard and basically got the go-ahead to infinitely push that, the gas pedal, proverbial gas pedal for money printing, it has really accelerated. And the point is that this is what underpins everything, right? This is what underpins credit, debt, institutions, solvency, all of these things. And whether there's a problem with all this because there's inflation, or whether there's solvency issues for certain people, or whatever it is, every single indicator within the lessons of history shows us that we really pushed this gas pedal really hard. If you look at the central bank balance sheet as a share of GDP, if you look at the percentage of all dollars printed throughout the last couple of decades, over 20% was printed just last year. And then you think about the things that have been happening over the past 2 decades, both with the credit crisis in 2008 and the Greek banks denying access to funds in Europe back in 2015. I think you start to see that, the just trust us set of guarantees
in various ways is fraying. And once again, the amazing thing is that there is finally, throughout history, there's never been an alternative, but finally there is an alternative to the just trust us model. And that is what we are doing, and that is what our industry is about. And that's quite an amazing difference. So I'll give you an example, a modern example, right? So a modern example of this is Robinhood. Robinhood is a TradeFi product that basically gives a just trust us paper promise that says, do whatever you want, whenever you want, just trade, just do whatever you want, just have fun. Good luck. Have fun. Okay, sounds great. People were doing that. Oh no. Turns out we can't do that. Why can't we do that? Oh, you didn't read the fine print. In fact, you did read the fine print, but we changed the fine print. You know, that's what a paper promise looks like. That's probably the most modern, most well-known example. You know, it's not any better or worse than the other paper promises that are out there. I'm just using it because it's the example that people know. But it's a very poignant example. It's a very clear example of, hey, I made you a just trust us promise. Nothing was forcing me to guarantee that to you. Nothing was forcing me to do that. Nothing was forcing me to actually deliver on the promise I made to you other than my desire as an institution or as an entity. And I didn't. I just said, hey, you know, I'm not going to do it. Tough luck. Tough luck, everybody. Right? The just trust us tough luck era of 1,000-something years is now going to come to an end. Right? That model of just trust us and we'll do whatever we want is coming to an end. And that's a very, very, very different way for the world to work. For example, how does DeFi work in those situations? Well, in DeFi, you have certain cryptographic guarantees. You have certain code that is guaranteed to execute in a certain way. And what does that mean? Well, that means it's guaranteed to execute in a certain way, and you're not going to get away from executing it that way. That's quite amazing, because that means that no matter what anybody decides, no matter what the person who made the application decides or what someone else decides, you're going to get the behavior you expect from the financial system, for the financial product, from your assets, from your custody solution, from whatever. Never before in history could you generate that type of promise, that type of guarantee on the basis of math, physics, encryption. Never. No one ever could give you that guarantee until about 2009, where if you had a private key, you had control over something that no one else could stop you from doing things with because you had the private key. So that's a big deal. And I once again just want to underscore this so people understand what it is that we're doing here. Why does it matter? Why should we care about blockchains? Why should we care about oracles? Why should we care about smart contracts? It's not just about finance, and it's not just about gaming, and it's not just about insurance. It's about the way the world works. And the way the world works influences everybody. It influences developed markets. It influences emerging markets. It influences the average consumer. It influences institutions. It influences everybody. And at the end of the day, the way we're going to make the world work, and the way we're already making the world work to the tune of over $1 trillion in our industry, is cryptographic truth. That's the alternative. In cryptographic truth, there isn't some person somewhere that decides what happens. There's math, there's encryption, there's physics. And as long as physics and encryption and math works as expected, which is about probably the best guarantee you're going to get in this world, you're going to get what you expect from the financial system, from an insurance product, from a gaming system, from an ad network, from whatever. That's so different that people who aren't used to considering that, I think many times can't even process the full difference. But the difference is like night and day. It's the difference between having assurance that something will happen and having the possibility that it won't happen. And I have to tell you, in every single case where I've made this distinction clear, with every enterprise, every startup, every individual person, I have yet to meet a person that is going to tell me, you know, I would prefer a just trust us promise where, you know, things can get switched up on me at any moment. Just switch them up. It'll be fun. Nobody has ever said that to me once they understand the distinction. And that gives me an immense amount of surety that if we are able to provide cryptographic truth to the world in an easily consumable, secure, easy to use, easy to implement manner, then that is how the whole world will work. Because nobody so far has ever told me, no, I would just like the paper promise where, I could be screwed. Let's just do that. Never heard that once. This is why our vision at Chainlink Labs and what we hope Chainlink will do is build a world powered by truth. So we've done some work internally to solidify in the simplest terms possible what it is that we're doing, what we're hoping to achieve with the Chainlink open source project and community and network. And this is what we're hoping to achieve. We're hoping to build a world powered by truth, specifically cryptographic truth, but really to build a world powered by truth. As you can tell, this is rooted in our fundamental belief that truth is better than false, paper-based trust, right? So if you have the truth, you can build systems around it. If you have to just trust some paper promise, some institution, some whatever, that is strictly worse. That is inferior. So truth is greater than trust. That's what we mean when we have this statement. This is at the core of our fundamental belief system. And how we're seeking to achieve this is to build decentralized systems that link everything to truth, creating a fair, unbiased world. So that's fundamentally what Chainlink Labs does. That's what the Chainlink network will hopefully achieve, is become a set of decentralized systems that link everything to truth, creating a fair, unbiased world. And that is going to be a world that's much better to live in for everybody. For developed markets, because there aren't just a small number of people that can just take money from society and everybody else, and in emerging markets, because they'll finally have access to agreements and contracts and capabilities that they never had access to before. So this, I think, is a very worthwhile goal that we have. This is how we're approaching it. And I just thought in the first few minutes of the presentation would be useful for everybody to get on the same page of why this is important, how we're seeking to achieve this, and what it is that our fundamental beliefs are in terms of what we're working on, and ideally, I think also in this industry. How is this achieved? So this is achieved through creating more and more advanced hybrid smart contracts, right? So something that people, I think, need to understand is that the more advanced smart contracts become, the more industries, the more use cases, the deeper into existing industries technology from our industry goes. The more smart contracts can do, the more blockchains are involved in the financial kind of world. The more blockchains and smart contracts can do, the greater share of gaming is powered by them. The more smart contracts and blockchains can do, the more of the insurance world is powered by them. This is what we're doing. We are seeking to extend and augment and improve and enable and help build an entirely new, more advanced class of smart contracts that extend what blockchains and smart contract platforms like Ethereum and others are used for across many industries. And this will massively expand the pie. It'll grow the pie, it'll grow the market, it'll grow what our industry is about, and it'll make blockchains and smart contracts the source of cryptographic truth for how the world operates. And that's our fundamental goal, to transition the world from a paper promises, just trust us, hopefully it's going to work out model, to the cryptographic truth model that, in my opinion, requires smart contracts to be able to meet the operational demands of the financial industry, the insurance industry, the gaming industry, and all subsequent industries, where it will fundamentally change how they operate. Now, this works on three fundamental levels. You have the blockchain, which is kind of the root of cryptographic truth and trust that secures the state, secures the truth, secures the trust dynamic of the state changes. You have the off-chain world of trust minimized off-chain computation in the form of decentralized Oracle networks, which is what Chainlink specializes in. And then you have the world of existing systems, existing services, data providers, existing backends, existing payment systems, all the world's existing infrastructure for data, payments, backend computation, backend systems control, access control, so on and so on. Now, we in our model have divided up the off-chain portion of the world into three distinct categories, which I will be going through today. The first category is off-chain data, the second is off-chain compute, and the third is cross-chain compute. In terms of what this actually means, you already see all of this happening. So you already see multiple off-chain services powering DeFi, powering gaming, powering, wrapped assets like, WBTC. You basically already see the ability to provide price feeds, weather data, proof of reserves, random number generation to various protocols that all then interoperate with each other. You see their existence appearing because you have these services. So I'm very, very proud to say that our many long nights of effort and work by everybody here in the Chainlink ecosystem has already resulted in a significant change in our industry, has already resulted in a significant improvement of what our industry does, and has already grown DeFi well past what it was when we started, and is now growing other sectors of the blockchain economy by allowing people like weather insurance, insurtechs, and gaming companies, and custody providers to join into the benefits of using cryptographic truth in blockchains. And DeFi is just the initial example of this, which is really just getting going. But if you look at the model is multiple off-chain services being used by on-chain contracts that interoperate with each other to create really advanced applications, which then go into these finance industries, insurance industries, gaming industries, global trade industries, and begin to redefine those industries and begin to pull more and more value, more and more contractual transactional volume into the contracts, because the contracts can finally service the requirements of that industry, thanks to this combination of off-chain systems together with on-chain advanced code, which is enabled by the off-chain systems. So we are already doing this, and we're very, very proud of that, and I think we should be very proud of that. Our fundamental goal is to create a global standard for enabling cryptographic truth by augmenting blockchains, improving what blockchains do, enabling blockchains to be more useful, enabling smart contracts to do more. In the history of global standards, I think you see a very useful pattern in that HTTPS, as an example, what is it built on? It's built on being an open source standard that had the first best technology, that was built on superior security, and now it services most web traffic. Similar story with Linux. Open source standard, innovative first mover, built on better security, services most web servers. With Chainlink, what we are working on diligently and kind of feverishly at this point is making sure that it's the global open source standard. We are clearly the innovative first mover that's actually accelerated certain industries like DeFi into what it is today. We are definitely built on better security based on the preference that everybody has in using our data and our other services. And as you can see, we service more smart contracts and are rapidly adding to that list. So our fundamental goal is to create a global standard that will change the way that our industry is used, improve society, improve how the world works, and write our name into history in the process, just like HTTP is, just like Linux. That is our fundamental goal. That is the kind of journey that we're on. That's what we're focused on doing. Luckily for us, we have the resources to do that. We have over 250 people working on that at Chainlink Labs, and lots of other people and lots of other teams building that. And we have a huge community of users and node operators and other really smart people collaborating to make that happen. But that is the fundamental goal of Chainlink, to become the global open source standard for how cryptographic truth is enabled on top of blockchains, on top of smart contracts, to make blockchains and smart contracts useful for the larger world. And there is certainly a lot that they are useful for. Now, if we look at this in a very general initial sense, what we really see is various services, various decentralized services, enabling distinct industries that would not exist and could not properly function without those decentralized services, serving them in the secure, reliable, low-cost, high-speed manner that they are. Now, the first and best example that we're known for about this is price and market data, which, as many of the people that we work with and many in the community know, has accelerated and allowed the DeFi industry to grow into what it is today, which is why we serve the largest lending protocols, the largest derivatives protocols, the largest insurance protocols, and why when they launch new markets, we make sure that they have the secure, reliable data that they need. This is done through a complicated system that was architected with a secure systems design set of principles that other solutions don't seem to have, and that have been tested over time against flash loan attacks, congestion to the tune of 2,500 gas, which we have always overcome by putting in updates, while other Oracle systems have not put in updates, and various other innovations that make sure that our systems operate. This is why the majority of DeFi uses us, and why even more DeFi applications are automatically integrating us on their own to make sure that they have a reliable system of data. Now, what this has shown us, this initial interaction with DeFi, which is now still, in the 70 to $100 billion market size range, which is very, very small compared to where I think it will be, is that all of the world's financial contracts, financial products, financial incentives, ownership rights, carbon credit systems, insurance processes will eventually be in a smart contract. That is what I personally believe very, very strongly. There is absolutely no reason why they wouldn't, if we as an industry can make the transition of carbon credits, derivatives, capital markets, real estate, commodities, insurance, if we can make all of those industries able to transition to blockchain-based smart contracts, to hybrid smart contracts, to Oracle-powered systems and smart contracts, that is what we can achieve. And when we achieve that, the same diagram you saw for DeFi, where different DeFi protocols are composable, will take place for all of the world's markets, whether that's carbon credits or capital markets or insurance markets or commodities markets, it doesn't matter. They all want to function in this hyper-reliable way. And the DeFi world is a microcosm of that. It is a precursor. It is a signal and a sign and a picture, an early picture of what is to come. And I personally think that this is inevitable. It is completely inevitable. The only question is, how quickly can we do it, and how quickly can we get it to benefit emerging markets and to benefit developed markets? And my other personal belief is that the speed at which the just trust us guarantees of society fail, and the just trust us model begins to show that it doesn't fulfill people's expectations and needs as consumers, is also going to accelerate this. But this is where everything is going. After enabling all of this DeFi stuff, after seeing how it interoperates, after talking to multiple banks and various other institutions, all of the world's contracts will be a collection of services interoperating with each other across a number of different chains, vertically focused chains, geographically focused chains, private chains, public chains, but they will all be on a blockchain because of this superior cryptographic truth guarantee that they don't have anywhere else to get, and that they will desperately want the more that the just trust us paper promises world shows its inability to guarantee solvency, reliability, and just, to be unpredictable generally. People don't like unpredictability. They like guarantees that are actually fulfilled. And that's what our industry is about. Our continual goal is to provide more and more and more services. More and more services means more and more smart contracts. More and more smart contracts means more and more usefulness for various industries. More and more usefulness for various industries means more and more adoption of smart contracts. And that is the cycle. That's the virtuous cycle. The more we can enable smart contracts to do, the more useful things they will do, because they do extremely useful things. And then the more they'll get adopted, which will lead to even more services being in demand. Proof of reserves is just one simple example. It's the ability to replace a one-year audit process that has historically failed society, whether it's through Enron or Wirecard or any number of other examples. That one-year auditing process where everybody's buddies with the auditors and the auditors missed something or didn't see something or, were somehow having a conflict of interest. That one-year audit window, I got to tell you, if you give people a choice between a one-year audit and a 1 second audit, automatic audit with cryptographic truth, proving every single thing that was audited and that the place where it came from proved that the assets were there, that they were at a certain value, that they were in a certain state. I don't know a single person who's going to tell you, I'd like a one-year audit. I'd like a year of risk. Give me a year. I'd like to take risk for a year. Nobody will want that. Everyone will want automated cryptographic truth-based audits. And you already see that from the organizations that understand how cryptographic truth can allow them to provide better guarantees. Now, once again, that's initially crypto firms, certain fintechs, right? Certain CeFi. But the fundamental kind of proof and cryptographic truth benefit compared to other things is just, you know, hundreds of times better. And everybody can verify it. In our proof of reserve schemes, everybody can verify the assets that certain stablecoins have in bank accounts, in gold vaults, on a block by block basis. So block by block, you know what's backing a stablecoin because it was proven to you by a data source that, you know, shows that. And what does that do? That makes it so that if anybody wants to under-collateralize that stablecoin, what do they know? They know that they will be discovered within 10 seconds. That's not a year. You can't take some money and hope to put it back in 10 seconds. It's 10 seconds. That's another example of a difference. And beyond that, it just expands, right? So highly validated data is the first category where once you generate highly validated cryptographic proofs about what's going on, you can then prove what is true, what happened, what didn't happen. And then around that truth, around that cryptographic truth that was proven through, you know, a definitive method of generating a consensus about what happened, you can then build all kinds of systems, all kinds of innovations, all kinds of things that weren't possible previously. And this is the amazing initial step that we've taken that has given birth to DeFi, given birth to proof of reserves, given birth to some decentralized insurance products, better versions of fraud-proof gaming. Here are just some examples. You know, one of my favorite examples, quite simply, weather insurance. Based on what's happening with the weather these days, I think you can see why it's one of my favorite examples. People need weather insurance. There's a flood there. There's a forest fire here. There's rising sea levels there. There's lack of rain somewhere else. That's not going to stop, first of all. Second of all, how do people manage that risk in places that don't have insurance companies? What do? You know what they do? They pray. They pray to the rain god. That's very nice, and they should do that if they would like to. But, you know, that's not really going to work if there's no rain. That's not going to give them solvency. That's not going to allow them to continue being an emerging markets farmer. You know what they should do? They should do whatever they want to do to help make rain happen. And then they should have cryptographically guaranteed insurance that doesn't depend on their local legal system. The only thing it depends on is them having a $50 Android phone in their hand and internet access. And then all of a sudden, through insurtechs like Harbol, you can suddenly have people in all kinds of parts of the world where their local legal system doesn't work. The insurance companies aren't going there. The ones that would go would be predatory. You know, there's payday loan people who are predatory. There's banks that are highly predatory with just crazy usury rates. And they can just sidestep all that because you now have a system of contracts based on cryptographic truth. We can verify whether there was rainfall. They can sign up for the insurance with the cryptographic proof, and they can automatically be paid what they're owed, not because an insurance company says, I feel like it, but because it is enforced by math and physics. And now somebody with a $50 Android phone and an internet connection that hasn't heard of an insurance company up until now can have better insurance guarantees through cryptographic truth than people in developed markets that are still stuck with paper promises. That's unbelievable. And more importantly, that will completely change that person's life. That will allow them to continue being a farmer, or it'll allow them to continue, selling meat or building construction things or whatever they're doing. And this is the underpinning of society that isn't seen by people, but which underpins how society works that we're changing. This is partly dependent on our ability to generate these cryptographic systems, our community's ability to help build Chainlink, and the inclusion of data providers. And I'm really encouraged to see large and impressive weather providers like AccuWeather basically going on and running their own Chainlink nodes and providing their data to various blockchain networks eagerly in order to service all of these smart contracts. Because there is a huge world of data, and everybody does want it to be used to achieve these critical, massive changes in how society works. And the place where that is going to happen is the smart contract state on blockchains. And all we really have to do as an ecosystem and as a project and as a group of people is make that happen. We have to get the data and the things that all of the smart contract developers need in order to build the future and to build this cryptographically truth-powered world. We need to get it to them. We need to give it to them in a secure, reliable, decentralized way. And if we're able to do that, it'll change our industry. It'll change the way the world works. And I personally think it'll make Chainlink a global standard, which is once again our goal. Other examples of this are very straightforward. NFTs. NFTs are really impressive. They're great. But even more impressive are dynamic NFTs that are updated by what happened, right? So if you own some kind of sports-related NFT, with the help of Chainlink networks and the data and sports data, you can keep it updated, and the value of that NFT can be tied to what's happened in the real world. That's called the dynamic NFT. So that's a great gaming example. Other examples are things like identity, where you're able to verify identity for something like a decentralized domain system like Unstoppable Domains through Twitter. And you're able to connect various points of identity to a domain system like Unstoppable Domains or ENS or others. And identity is something we're working on as another source of data. But this is just to highlight that there's large varieties of other data that will continue to generate large varieties of other critical use cases, which were previously unavailable, and will once again reinvent what our industry is about. And that's what I think we should all be focused on, and that's what I think we should be doing. The next part of this chapter in enabling developers to build more and generate even more impressive things is off-chain compute. Now, when I say off-chain compute, I mean trust minimized off-chain compute. I mean off-chain computation that isn't done in a centralized web server, but it's done in an Oracle network in a way that creates some degree of trust minimization so that you still have decentralization around the computation, but you can still use it to do things other than what you would do in a smart contract. This is an entirely separate category where so far we have generated randomness very successfully for many gaming applications. Now we are moving on to Keepers, automation, and more advanced off-chain compute. And beyond that, there's expanded computation like FSS. So far, in less than a year from going live, the verifiable random generation systems that we've put out are now generating over 200,000 VRF requests per month for many of the top games in the blockchain industry. And what that shows me is that not only is data and the access to various data, identity data, weather data, price data, market data, location data, whatever data, not only is data a critical component of building more advanced smart contracts, but computation and certain specific types of computation that need to be trust minimized are also a key aspect of building smart contracts in an advanced, more useful way that's going to reinvent our industry and reinvent how the world uses what we're building in this entire industry. This is why we are today announcing that Chainlink Keepers is going live on mainnet. Chainlink Keepers has been in the works for a while, and it has been open beta for some time, just kind of soak testing it and making sure that it's secure and ready. And we're thrilled to say that today it's going live on mainnet and basically launching for use by all of the DeFi apps out there, and will be coming to all the blockchains where we integrate pretty rapidly. Now, Chainlink Keepers is fundamentally the ability to give a computation to something called a keeper network, to give a computation that isn't something you can do in a contract or you want to do in a contract for either capability reasons, the contract can't do it, cost reasons, the contract would be too costly to do it it would be too costly to do it in a blockchain, or sometimes privacy reasons. The other reason that we found is realistically, just like you had a centralization problem with data, where people would run their own oracles and those oracles could fail, and that failure could lead to a DeFi protocol being, underwater or dislocated from markets or dislocated from reality. It's very much the same situation with Keepers. You have developer teams and developer communities that are building a great DeFi application, a great gaming application, but they don't want to build infrastructure and they don't need to build infrastructure. And that's the problem we need to solve for them at Chainlink. And the Chainlink network needs to be built to solve by the larger community, by them together with us and so on. It's a matter of providing a decentralized system that you can offload the responsibility of off-chain computation to, while still having those off-chain computations have a measure of decentralization and trust minimized guarantees, right? So the way it really looks is, hey, I'm a smart contract development team. I know I'm going to do 1,000 contract calls about a certain topic, whether that's telling the contract what time it is. You know, for example, smart contracts can't know what time it is. They need a server. They need a central server to tell it it's midday UTC time, time to settle, time to execute. Even that level of information isn't available to the contract, just time. And so these developer teams know, hey, I am going to have 1,000 plus interactions with a smart contract. Man, I hope I can keep my server running. Man, I hope I don't miss one of those, because if I miss one of those, it'll be really, it'll be a real problem. So instead of having to do 1,000 of those and not being able to tell their user base that they're giving them reliable guarantees, now they can quite simply say, here is one upkeep request into the Chainlink Keeper system, into a single Chainlink Keeper network. And then that Chainlink Keeper network will do thousands of ongoing DevOps, off-chain compute, and other transactions. Now, why does this matter once again, right? Just to explain this kind of slightly esoteric problem. Why does trust minimized off-chain compute matter? Well, once again, when you're building decentralized secure systems, you need to be secure and decentralized and hyper-reliable end-to-end. So you need to be hyper-reliable when the gas price is at 2,500. You need to be hyper-reliable if a server somewhere goes down. You need to make sure that your systems run in all market conditions, in all network conditions, because that's the nature of blockchain-based applications. You need to provide that cryptographic truth guarantee that under all circumstances, you will be able to generate the outcome the application says it will generate. So how does this look when everything's okay? Well, when everything's okay, the smart contract development team, is triggering things based on time, maybe doing limit order execution through their interface, maybe doing automated liquidations, maybe doing some smart contract DevOps requests. Someone on their team is maintaining a central server. That central server essentially decides how the application will and won't function because it controls certain key outcomes of what the smart contract application is able to do. And that is a very, very striking parallel to oracles, right? Data oracles. Same exact story. Guess what? That's a bad idea. Same reason. You don't want a centralized system controlling your contracts, whether it's for data or telling it what time it is or triggering it for various key events that you would ideally offload. And the place where that starts to get shown is when gas does go to 2,500 and transactions aren't being broadcast, or your centralized server fails, or an adversary finds out how to DDoS your one centralized server, and all of a sudden you're not broadcasting DevOps transactions to your smart contract. Those are all very exploitable, very risky things that Chainlink networks expressly eliminate, right? They expressly eliminate the congestion issues, the network issues, the market-based issues, the exploit issues, all of those. And that's been proven, which is why, once again, the Chainlink networks that provide data, hundreds of those now exist, going to thousands soon, and those networks provide that data under the same set of guarantees that Chainlink Keepers will provide to the applications that now need a reliable method to compute key computations that the contract cannot do, but that have to be done in a decentralized, trust-minimized, hyper-reliable manner. And so that's the fundamental role of Keepers. And this, once again, serves the purpose of, firstly, unburdening the smart contract development teams from having to do this so that they can focus on making a great DeFi, gaming, or insurance application. And secondly, providing an end-to-end decentralized guarantee for how the application functions. And this guarantee is what all of this is about. All of this is about a decentralized smart contract with end-to-end security, end-to-end decentralization. This is what end-to-end decentralization looks like, not this. Now, here are some examples to provide clarity. So in the case of Aave, we're working with them on reliably managing the liquidations in their protocol to make sure their protocol remains solvent. That means that the various liquidations that need to happen for their protocol to remain, above water and solvent and usable will now, in many parts of their kind of smart contracts, be done by Chainlink Keepers. that will provide guarantees about liquidating those things, about getting transactions in about that, about properly monitoring that. And that's a critical aspect of keeping the Aave protocol working properly. In the synthetics case, it's about staking and fee distribution. And so there needs to be a mechanism to properly stake, give out staking rewards, fee distribution, and so on. And this is a very, very clear need in many different applications where a keeper network is now going to take on the role of making sure that that part of the application works properly as an off-chain trust minimized computing resource that's configurable by the synthetics community and the synthetics team and through whatever set of processes that community has. And then another final example is pull together for something as basic as starting its games and ending its games on the basis of time, right? So instead of the pull together team having to initiate these critical aspects of their game, they can now offload this responsibility to a hyper reliable, decentralized computing system in the form of a Chainlink network that's committed to doing this, just like it's committed to providing data and under the same set of hyper reliable systems guarantees, in reliable systems. So this is a big, big improvement for what smart contract developers can build today. They can offload a massive amount of DevOps, a massive amount of automation, a massive amount of computation that their team has to do internally. And they get their developer resources back. Their protocol becomes more decentralized, and their protocol can prove more cryptographic truth to their users. So it's just a benefit all around, accelerating what can be built. The more expansive vision of Keepers that I'm truly excited about, and I'm already starting to see certain protocols taking advantage of, is the ability to actually offload certain amounts of computation into a Keeper network. So the way that this looks, and in practice it can actually be done today at this very moment, is the broadcasting of a smart contract on chain into a network like Ethereum. That contract that was broadcast and deployed on chain then can be split into two equal parts. It can have a portion that is supposed to be executed on the blockchain network, and then it can have a subsequent portion, maybe even a very large portion that would be extremely costly to run on the blockchain network in the Keeper network. So the Keeper network, basically at no cost, or just like web systems cost, just base minimal hardware and web traffic cost, which is like the lowest cost you're going to get for any computation, can now execute a portion of the code that was broadcast and deployed on chain. Now, the benefits of this are twofold. Firstly, you've deployed the code on chain, so everybody can verify what the Keeper network is going to compute for you. That Keeper network is only for that contract, and it is not going to compute anything else for anybody else. It's not going to do anything else. It's a distinct service that only computes that piece of code for that one contract on a committed SLA type of basis. And so everybody knows this Keeper network has committed to run that code, which has been deployed on chain. So now you know that this trust minimized Oracle network is committing to run that code. So you have certain assurances and certain cryptographic truth and certain transparency there. And then the Keeper network runs that code. So if you had a contract that you wanted to make more robust, you didn't want to pay a lot of Ethereum fees, or you wanted certain privacy about that code, guess what? You can broadcast it, and then you can have it run in the Chainlink Keeper system. And the Chainlink Keeper system can look at a multitude of on-chain and off-chain activity. And this is a very, very extensible capability that we already see some of the protocols we're working with that are using Chainlink Keepers doing. We're seeing them basically say, hey, I want a more robust, more advanced hybrid smart contract. Here's what I want happening on chain for cost or speed or whatever other reasons. Here is the code that I want to run off chain in a trust minimized way. And here's what I needed to do. I needed to tell me the time. I needed to go get some data. I needed to compute some things. I needed to compute something else. Once you see the results, I needed to monitor a contract somewhere and then do something based on that monitoring, because smart contracts, can't even really monitor each other unless they're kicked by a Keeper system. And so this is extending to a very large degree what smart contract developers can build with a trust minimized system that generates cryptographic truth on that topic. And so that's quite an amazing innovation, in my opinion. And I think it's going to generate a lot of very advanced use cases. Now, if this is something that you would find useful, if you're a developer, if you're building various blockchain-based applications, I think you should really check this out. This is a decentralized, easy-to-use form of off-chain computation that in a matter of minutes can allow you to offload some of your centralized responsibilities to a decentralized system that you can configure. You can add more nodes, you can add less nodes, you can expand what the nodes are computing for you, and you can prove all of that to your users so they know that this portion of your smart contract is not run by you, is not in a black box, but it is in this cryptographic truth, decentralized, completely end-to-end provable model, which is the model that I think everyone here is going towards. The next aspect of what we're working on, and what I think it's important to say, is the cross-chain compute aspect, right? So there's the off-chain data and the off-chain services and the off-chain payment systems that Oracle networks allow contracts to use. There's the off-chain compute that you can't do in centralized systems because they don't have a trust minimized aspect. You need to do them in some kind of trust minimized Oracle network-like system. But then there's also the cross-chain aspect. And the cross-chain aspect is actually the way to make some of the most advanced smart contracts, and really the smart contracts of the future, what we call cross-chain dApps or cross-chain smart contracts. It's the ability to string together multiple smart contracts from multiple chains using one smart contract, for data. Maybe there's a supply chain blockchain somewhere with data about, what's going on with a good. Maybe there's another blockchain somewhere that you want to do a payment in. Maybe there's another blockchain where the contract itself operates. And then maybe there's 5 other blockchains that you want to use to generate various DeFi, DeFi interactions. This is why, we're quite proud and very excited to be announcing CCIP. So CCIP is something we've been working on for many years. In our initial white paper, we made it very clear that we want to support all leading smart contract networks for both off-chain and cross-chain interactions. And CCIP is similar to TCP/IP and other protocols that seek to provide connectivity and seek to make disparate different systems work under one messaging and under one communications standard. So CCIP is really about creating a global open source standard such as TCP/IP or others that will allow blockchains to interoperate with each other, will allow smart contracts from different blockchains to send each other commands, and obviously enable the movement of tokens between chains. And this is the final piece of the puzzle that we are now very, very focused on and have already been working on for years, about how we want to enable a truly cross-chain set of smart contracts where all the different features of all the different blockchains and all of their different capabilities really need to be something that we give people access to. Because giving people and developers the ability to generate a smart contract on Ethereum, use DeFi protocols on other chains, send a payment on a Hyperledger payment system, maybe get collateral in Bitcoin, or do whatever complicated combination they want to do, is something that will unlock an entire world of innovation in our industry. It will unlock an entire new set of applications that were previously not available and previously not possible. And that's why we're doing this, right? We're doing this because we want to enable hybrid smart contracts to reinvent how the world works through this collaboration between different smart contracts, different chains, different capabilities. And we are positive, and we already see a huge demand for the ability to use multiple applications on multiple chains, multiple services on multiple chains, multiple smart contracts on multiple chains. So this is now the expanded definition of a smart contract, right? The initial definition of a smart contract might have been a tokenization contract, and that's it. And then it expanded to a tokenization contract with a voting contract. And then it expanded to a tokenization contract with a voting contract that uses a data feed. That's DeFi. And then it expanded to, tokenization, voting, off-chain data feed through an Oracle network like Chainlink, and maybe some off-chain computation. That's more advanced DeFi. And now, with the help of the work that we're doing on CCIP with the large and growing community of contributors and thought leaders working with us, I think what you'll see is that a smart contract will actually be defined by a tokenization contract, a voting contract, a multi-sig contract, a few off-chain data feeds, a few off-chain keeper systems that do computation, and a few other contracts in a few other places that provide distinct services and tokens and DeFi and other capabilities. And that will be the definition of a smart contract. That will be what a smart contract is. And that will be better for everybody, because the amount of capabilities that are going to appear from that is once again going to grow the industry. It's going to grow the industry based on the usefulness that that's going to provide to the entire blockchain ecosystem, to the entire world. And once again, that's our goal. Our goal is to grow the usefulness of the industry, just like DeFi has grown the usefulness of the industry with the help of off-chain data. And that's going to be a recurring pattern. More off-chain services, more off-chain capabilities, more advanced smart contracts, more useful things for society, more users coming in and building things, using things that have blockchains. And eventually, it'll lead to a larger kind of societal and collective consciousness understanding of cryptographic truth. Because if you're getting cryptographic truth in one part of your life and you're not getting it in another part of your life, you're confused, right? You're thinking, hey, I have all these great cryptographic truth guarantees in my financial part of my life, but my insurance company isn't giving it to me. I don't think I like that. That's what all of this is going to result in as we gradually provide capabilities to developers and they gradually build more advanced smart contracts. That's how we get our industry from 1.5 trillion to hundreds of trillions, to powering how the world works. Now, one concrete example of this that I'd like to walk through is our work with Celsius. So we're very proud to be working with Celsius, who has over 16 billion in total value locked in their systems and close to 1 million users using them to generate yield on their cryptocurrency. Now, Celsius is an interesting organization, an interesting company, because with our help and with our collaboration, they're actually combining certain centralized systems with certain decentralized systems on a progressive and more rapid basis. And one of the things that CCIP and the ability to bridge value into other blockchains will allow them to do is it'll actually allow them to use various DeFi protocols such as Aave. And it'll allow them to use those protocols on different environments like Ethereum or Arbitrum or others. And so Celsius's plan, and I think this is going to be the plan of many different user-focused applications, and eventually the plan of many banks, and eventually the plan of many fintechs, is how do I interoperate with all of the useful smart contracts in all of the environments that can provide value to my user base? And more importantly, how can I do that with the most security and with the minimal technical investment? Both of which the CCIP standard and our approach to programmable bridges provides, which I'll go into more detail here. So generally speaking, what you're going to be seeing with the CCIP implementations is people like Celsius sending both commands and tokens to a CCIP-enabled programmable bridge. And what programmable bridge means is that they will send both the tokens and the instructions of what to do with the tokens to the bridge. The bridge will then move the tokens into relevant protocols according to the instructions that were given to it by somebody like Celsius. So the bridge is not just moving tokens and saying, good luck, I hope you know where to send them, or I hope you know what to do on whatever blockchain. The bridge is accelerating the speed at which Celsius and other cross-chain dApps, right? Because in this case, Celsius is very much becoming a very, very cross-chain enabled dApp and kind of collection of centralized and decentralized systems. It enables them to rapidly both send tokens and send the commands and instructions of what to do with the tokens, which means they don't necessarily need to deeply integrate with anything. They just need to send the tokens and the instructions. And now they can easily utilize not only multiple chains, but multiple smart contracts on those chains, such as Aave. And this is a huge benefit for everybody. So the first thing that it does is it allows Celsius and their users to gain access to all these different chains and all their different smart contracts. And the second thing that it does is it provides massive amounts of value to those protocols on those blockchains that want to interface with that user base, right? So Celsius has a user base of close to 1 million users with 16 billion total value locked. That's growing pretty rapidly. Aave has an amazing lending protocol that can reliably and with the help of various cryptographic truth guarantees provide a lending dynamic that other systems that Celsius has access to can't. And Celsius's users may want to use Aave, and they may want to get their yield from there, and they should absolutely be able to do that. And more importantly, they should be able to do that on all the blockchains where Aave has lending markets, because one of the lending markets might be better, or one of the lending markets might be about something that isn't somewhere else. And so this is an example of a cross-chain application that is leveraging CCIP, leveraging programmable bridges to get to the next stage of building advanced smart contract applications. And this is the picture of what's to come, because they're leveraging external data, they're leveraging Cross-Chain Interoperability, the Cross-Chain Interoperability Protocol, CCIP, they're leveraging programmable bridges, and what it's getting them is a more transparent system that proves to their users with various sources of cryptographic truth what's going on. It's allowing their users to use more applications and get more useful outcomes from various smart contracts. And it's fundamentally kind of changing their relationship with the entire blockchain industry. And so this is what we want to achieve with CCIP. Generally speaking, CCIP is a part of a larger stack with a number of different stakeholders and a number of different community members and a number of different kind of parties that need to fit into a larger holistic model. And that holistic model, is basically based on our viewing of it on these, 4 levels. And then it has 1/5 kind of critical aspect and system that we provide on the right here, the anti-fraud network. So the first level is the consensus and transport level. This is the computing infrastructure. This is the physical computing environment, which is, not surprisingly, the Chainlink networks, right? The Chainlink networks using OCR 2.0 will be able to generate even more efficient computations on a greater amount of topics. So OCR 1.0 was the protocol we released to increase the efficiency of Chainlink's ability to deliver data by over 90%. So almost a 10x increase in efficiency, which allowed us to scale the amount of Chainlink data related networks to hundreds and soon to thousands, and which allowed us to really generate a faster response time, a cheaper response time, and so on. OCR 2.0 is going to have an even greater, it's not going to have a 10x improvement on efficiency, but it's going to have a very large improvement on efficiency. And more importantly, it's going to provide a more generalized computation capability for things such as signature aggregation about events on various blockchains. So OCR 2.0 is the consensus methodology at the core of the cross-chain bridge and at the core of the Chainlink networks that will be generating the consensus to approve various transfers between chains, whether those are messages or whether those are tokens. Now, the other thing that OCR 2.0 does is its efficiency gains allow us to add even greater amount of nodes. So if you've seen some of the things going on today at the conference, you would have seen large enterprises like Swisscom joining the Chainlink network and becoming node operators alongside other node operators like T-Systems from Deutsche Telekom and other enterprises in the future. So what you're really seeing is the highest quality validator set, the highest quality node network in the blockchain industry is only going to become more high quality. And OCR 2.0 is going to only allow a greater and greater conglomeration of larger and larger node networks. And so if you look at the other cross-chain bridges, you'll see 2 things. You'll see certain cryptographic mistakes about how the protocol is built that have involved losses of funds in the tens of millions because certain cryptographic primitives were improperly connected and the fundamental principles of the design were flawed. And then you'll see node networks in the single digits. And node networks often made up of a relatively small amount of node operators that are either anonymous, so you don't know who's controlling the cryptocurrency, or individuals, just a single person who doesn't have a security background, who doesn't have a DevOps background. Obviously, those people can join Chainlink networks and can make Chainlink networks. But if you're going to have a physical compute infrastructure, a decentralized infrastructure that eventually secures trillions of dollars in value, you want to have a system that gets you the best node operators, that directs fees towards the best node operators, and that progressively improves the quality of the network as the value secured by it grows, which is the distinct advantage that Chainlink networks have, and that OCR 2.0 only accelerates because it allows us to add even greater amounts of nodes, such as hundreds of nodes, into a Chainlink network that is bridging, let's say billions of dollars. The next level is CCIP, the Cross-Chain Interoperability Protocol. Fundamentally, CCIP is an open source global standard that we're collaborating on, that we're collaborating around with a number of important stakeholders, like Celsius, like various blockchains, like various DeFi protocols, like various bridge providers, various groups that need a reliable messaging protocol. So the CCIP is not necessarily about building a bridge. It can be used to build a bridge. It's about moving commands and information between chains, because it's those commands and information which will fundamentally make up any bridge. And so at the lowest level, you have the Chainlink Oracle networks coming to consensus using OCR 2.0, growing in larger and larger number with higher and higher quality node operators that have greater and greater amounts at stake to guarantee that the bridge is going to operate properly. And then you have a messaging system that has a very distinct purpose and a separation of concerns around messaging, right? Around the transaction of messaging and information and commands. And what this does is it enables cross-chain smart contracts, because smart contracts can now send commands to each other on different chains. It creates a global standard for blockchain interoperability. And very importantly, it enables various existing bridges, various current interfaces to build a better bridge, to build a better interface into various blockchains, because that messaging layer absolutely has to be secure. It can't be manipulated, right? You need the physical compute infrastructure, doing things in a decentralized way, coming to consensus about the signatures that need to be aggregated, about what messages to be sent. And then you need the messaging system to be secure. And so that's why those are the two primary levels we're focused on. We're focused on making a highly reliable Oracle network that can aggregate signatures and can verify things on various chains reliably, and a messaging protocol that can send messages to different chains in a hyper-reliable manner. Now, this is, once again, all about messages, right? So in subsequent presentations at the conference, you will see the details about the log system and the Chainlink message routing contract and a number of other things. So I don't really have time to go in this presentation, but what you'll really see is that it is about sending commands. It is about generating events that move between chains in a hyper-reliable way, so that one smart contract can say, I want to release a token from that contract in another chain, or another contract can say, hey, mint a token on that chain, or lock a token on this chain. And it's really about sending these commands through messages. So it's not necessarily about token movement, it's about generating a messaging protocol, and that's really what CCIP's focus is. Once again, as a global open source standard that we're collaborating on with multiple bridges, multiple external kind of DeFi applications, multiple CeFi applications, multiple blockchains, and so on. And what this is meant to do is just make everybody's life easier and more secure, so that the DeFi applications can get more value into them. The blockchains can interoperate with each other and get more interactions between them and various user bases that they want access to. The CeFi applications can usually use blockchains. It's really just a massive benefit for everybody, because everybody just gets more usability from our entire ecosystem. The next level in the cross-chain stack is the cross-chain services level. Now, the cross-chain services level is really about creating bridges and creating cross-chain applications. Bridges are more along the lines of using CCIP to generate token movements for whatever topic the application or the user wants, right? So the programmable bridge is an initial reference implementation that we've made and we're kind of making now, and we'll be releasing at some point, to show how you use CCIP to make a very advanced bridge. And advanced means not just the movement of tokens, but send my token to chain X and then monitor and put it into a DeFi application, monitor the yield of the DeFi application. And if the yield falls below a certain point, return it back to me. So you don't only send your tokens, you send your tokens and instructions about what to do with them. And the bridge abstracts away all the complexity of having to use that chain, of having to use those DeFi applications. You just get the benefit. You just get the benefit of that chain. You just get the benefit of all those DeFi applications. The DeFi applications benefit because they get far more usage this way. The chains benefit because the amount of transactions that they're executing for the DeFi applications or the services or the unique abilities they have, skyrockets. And the whole ecosystem benefits because everybody can just build more and more advanced things, which once again allows us to turn around to society and say, hey, we've built this amazing advanced hybrid smart contract. Here's what it does, right? It allows you to use all the different DeFi applications in this programmatic way. It's getting you even more value as a user. You should use DeFi because this hybrid cross-chain application can generate all this important kind of usefulness to you as a user. Now, once again, the Chainlink programmable token bridge is built on CCIP. It's a reference implementation, and we absolutely encourage other people to build bridges. So we want others to build bridges on CCIP. The reason we're focused on CCIP and not building bridges is because we want to provide the fundamental messaging layer and the fundamental Oracle infrastructure that is going to reliably execute the CCIP messages. The ability to build bridges is something we want other people to take on. The programmable token bridge reference implementation, I think, will be very impressive and very useful. And it'll have amazing features that I don't see in any other bridges, and it will have security guarantees that other bridges simply don't provide based on the way they're architected with the use of cryptographic primitives, or because they're not using Chainlink networks and they don't have a sufficiently large collection of nodes. Fundamentally speaking, what you're really going to see is a very large amount of messages. I think you're going to see a large amount of messages for a number of different bridges in the blockchain ecosystem, which I think don't fundamentally want to build the messaging layer or the physical infrastructure layer of node operators. I think they want to build a bridge that manages the movement of tokens somehow for different interfaces or even from their own interface. And that's what I've seen. I've seen a lot of people build bridges and then be forced to make a validator set or be forced to come up with a messaging protocol because they needed a bridge. And what they really want is a bridge. So we will have a programmable token bridge that we're absolutely thrilled for people to use. But we absolutely encourage other people to use CCIP to build their own bridges and to build even more advanced bridges. And then also to build cross-chain dApps that have their own unique bridging functionality built right into the dApp. So its own bridging conditions and its own messaging conditions built right into the application itself, right into different smart contracts. Once again, sending those commands over CCIP. The next level of the cross-chain stack that we focused on and worked on is the anti-fraud network. So the anti-fraud network, I think, is an amazing and unique innovation where we are able to generate an Oracle network, partly based on our work on proof of reserves, that monitors various key aspects of risk. So if you look at any system out there in the traditional world that moves any kind of value or anything, they always have a risk management and a fraud management and an anti-fraud department, and often a very complicated set of AI-driven systems. This is what the anti-fraud network does in a transparent, cryptographically truth-based, decentralized manner. It monitors all of the activity at all levels of the messaging system, the bridging system, and anything else that CCIP or Chainlink networks would be used for in regards to cross-chain communication, movements of tokens, or anything else. So the anti-fraud network is a separate parallel Oracle network sitting next to each cross-chain bridge that comes in the form of a DON, and it's at the most detailed level possible, monitoring the activity on both chains, what's happening with the minting, burning, locking, unlocking, what's happening with messages, are they being delivered, what's happening with the aggregated signatures from the Chainlink networks, are there any deviations, do those bridges need to be slowed down or sped up, what are the risks with those bridges? They're basically scanning for an endless collection of issues, reorgs, not enough confirmations, any number of risks. And then what the anti-fraud network does, similarly to what risk management and anti-fraud systems do in the real world, is they mitigate risk. So they manage risk in order to make it so that the Chainlink messaging protocol, the Chainlink programmable bridge, CCIP messages are all being accepted or not accepted according to the levels of risk that are deemed acceptable by users. Because once again, if you look at any system that moves around value, it has a dynamic like this. It has a risk management system, an anti-fraud system, a department that does this, AI that does this. And it just makes complete logical sense that if you're going to move critical messages between chains, if you're going to move tokens between chains, you want an anti-fraud system. But in the spirit of our industry and in the spirit of cryptographic truth, you want that anti-fraud system to be on a decentralized Oracle network. You want it to be transparent, and you want to know what it's doing, and you want it also to become more and more advanced. So this anti-fraud network can grow to extreme levels of advancement, possibly even running certain AI algorithms or any number of traditional anti-fraud mechanisms. So I think the anti-fraud network is going to be something extremely useful for bridges. I think it's going to be extremely useful even for users of CCIP. And I think it's actually going to have a life of its own in other categories of fraud management, even outside of the cross-chain world. This is one of the key innovations that we've been working on. As I've said, we've been working on CCIP, cross-chain, and all of these things for years. You can see, that this was our goal in the very initial Chainlink white paper. And this is one of those innovations that I think is going to have a very large impact on the ability to go from millions in bridges to billions in bridges to eventually trillions in bridges and flowing through something like CCIP. The next level of the stack is applications and user interfaces. Fundamentally, applications and user interfaces are either about cross-chain dApps like Celsius that are now interfacing with multiple different chains and need the security guarantees of that, or it's about just interfaces, various apps, wallets, lending interfaces, whatever interfaces that want to efficiently use different contracts on different chains. It's really about enabling all of these places that have large user bases, whether that's a wallet, an exchange, a crypto lending system, to interface and get the benefit of various chains. And once again, this benefits everybody. This benefits the user base of those apps and wallets. It benefits the chains because they're getting a greater user base. It benefits the DeFi protocols because they're getting a bigger user base. And it benefits our industry because once again, the applications people are able to build are just more advanced, right? And once again, that's our goal. Our fundamental goal is to provide a more advanced version of what our industry provides and to enable greater usability for the larger kind of global ecosystem of contracts, of finance, of insurance, of trade. And that is what will bring our industry into the future. That is what will make our industry about, hundreds of trillions of dollars, not $1.5 or $2 trillion. The fascinating direction that this goes in, right? The fascinating direction that this is really evolving in already now is the direction of the entire world's value flowing through a Chainlink abstraction layer. If you really think about it, and you think about what do web startups, web 2.0 firms with thousands of employees, fintechs, and enterprises with tens of thousands of employees want to do in relation to blockchains, the answer is they just want to use them. They just want to use the blockchain, and they only want to use the blockchain really for the reasons that they can use a contract on the blockchain. So what does CCIP do? And what does the Chainlink abstraction layer do? It enables people to send commands to various blockchains and even utilize various smart contracts from a single interface. This is absolutely fantastic and amazing for the entire blockchain industry, for the simple reason that the value locked in Web 2.0, fintech land, enterprise land, can now flow into blockchain networks. If before they were stuck in integrations, they were stuck in choosing the right blockchain, they weren't able to integrate with certain blockchains because they were somewhere lower on their list, or God knows what reason. With a single interface, Web 2.0, fintechs and enterprises can integrate with all the world's blockchains, with Chainlink being, announced and integrating with over 100 chains. And not only that, but they can efficiently use all the applications on those chains. That's a next level improvement of integration. And I personally think from our conversations with various enterprises that this is exactly what they need. They need to take all of their existing systems, all of their existing workflows, all their existing processes that they've trained 1,000, 10,000 employees on, or all their existing messaging protocols, all their existing routing systems for messages. They need to put it into an abstraction layer like Chainlink, and they need it to come out on the other side in a separate standard that allows them to reliably and in a provable manner interact not only with the blockchain, but also with the applications on a blockchain. So not only will they be able to send the command to a blockchain, but they'll be able to send the command to a specific contract. Personally, my personal point of view is that this extends even beyond enterprises. If we arrive at a world where CBDCs are on a blockchain, I personally think that there needs to be a global standard for how those CBDCs interoperate with other blockchain networks. And I think that's a far, far ways away. And I think CBDCs are very early. And I know there's a lot of, controversy about CBDCs. But my personal point of view is that if CBDCs are in a blockchain-based format, the ability for them to interoperate with blockchain networks and the ability for them to use DeFi applications will open the floodgates and will simply allow trillions upon trillions, hundreds of trillions of dollars to flow into blockchain networks, both public and private. So whether CBDCs are issued on blockchains or not, I don't know. But if they are issued on blockchains, then they will naturally need a solution to both interoperate with various enterprise systems, and they will need a solution to interoperate with various blockchain networks. And enabling that interoperation will be an extreme positive in the ability to allow trillions of dollars to flow into, the purchases of Bitcoin, the use of Ethereum DeFi, the use of gaming applications, the use of any number of other things. Fundamentally, if the world moves to a blockchain-based model, whether that's for supply chain data or global trade data or insurance-related contracts or CBDC, asset ownership or real estate ownership, what really matters is that the entire world moves to this cryptographically truth-based model. And our role is accelerating the interoperation, the access to data, the access to off-chain compute that's trust minimized for that to happen. And I personally think every single time that an enterprise integrates into a blockchain, any CBDC that starts to interoperate with a blockchain like Ethereum or Bitcoin or any others is going to bring a huge flow of value into those environments. And I think that is gonna really, really change our industry personally. So my personal goal is to build these decentralized systems, get as many people as I can using CCIP, building cross-chain applications. And if CBDCs do go in a blockchain-based way, then enabling the value from those environments to flow and to interoperate with blockchain systems and DeFi applications will be a huge win for everybody. This is what the Chainlink kind of universe of decentralized services looks right now. There's the validated data universe, there's the off-chain computation universe, now there's the cross-chain universe, which hopefully I've been able to create clarity about why that's very meaningful. Generally speaking, I think that this universe is going to continue to grow with identity solutions, with various other capabilities that we see smart contract developers need. We will not be making a blockchain. We will not be making DeFi products. We will not be making the smart contract applications themselves. Our goal is to accelerate what DeFi developers, gaming developers, insurance developers can do with blockchains. And that is fundamentally tied to enabling a greater amount of capabilities in the world's blockchains by attaching all of these decentralized services around them, right? So our fundamental goal is to provide price and market data, proof of reserves, all the world's data, random number generation, keepers and various off-chain computation, expanded forms of computations like FSS, bridging and messaging capabilities through CCIP and various programmable token bridge implementations that other people in the community build or whoever builds, and to fundamentally augment what blockchains can build, which we see as the critical missing piece, and which we've already seen greatly accelerate what DeFi can do. Our fundamental belief and what we've seen in practice is that as each cross-chain service goes, as each service goes live, as each decentralized service gains steam and has more Oracle networks, going from tens of Oracle networks to hundreds, and going from tens of users to hundreds of users, those markets just speed up, right? There's just more useful stuff being built. The markets speed up, more people build things, more people need services. So our fundamental cycle is, hey, here's a great decentralized service, build something cool. Okay, you as developer build something cool. Wow, everybody's using that. Wow, there's more developers that want to build that type of application. How wonderful. Here's more services to do that. Oh wow, we helped invent an entire category of useful smart contracts. How exciting is that? By the way, we're reinventing what smart contracts do. We're reinventing their benefit to society. We're reinventing all these beneficial aspects of what our industry does. So that's the ancillary impact of that. I once again believe that we are at the very, very, very early stages, just based on basic arithmetic, right? This percentage in some of my previous presentations was about 2.5. So the percentage in DeFi has grown. But as a percentage, it's still unbelievably low. It's still less than 5%. So if you think that 70 billion in DeFi is impressive, just another 5% and that doubles, right? I personally think that that's gonna probably 10x to at least 50% is gonna be in DeFi. And that means that DeFi is gonna be approaching the value of $1 trillion in DeFi. That's my expectation. That's what we're building towards. That's why we need to build hyper secure systems, hyper reliable systems, for whether that's for data, keepers and automation, random number generation, cross-chain messaging, whatever it is, because that's the world that we expect. That's the world that we're driving towards. If you go outside of the blockchain world and you look at the value that's outside of it, I mean, we're not even at the early innings of this. Like the game hasn't even started. Like we're at like whatever the pregame thing is, where there's like some music playing or something. We're at before the beginning, right? Most people haven't even come and taken their seats yet. It is unbelievably early. If you look at the amount of value that is going to be transformed into a hybrid smart contract based form, I mean, we're so far below 1% that it's not even worth mentioning. And once again, this is where I think the world is going. This is where we want to take the world. We want to go to the place where the entire world operates based on cryptographic truth. And there's actually industries missing from this diagram. The gaming industry isn't on this diagram. The insurance industry isn't on this diagram. The trade finance industry for global trade isn't on this diagram. A bunch of other industries like the ad network industry aren't on this diagram. All of those are going to be powered by cryptographic truth. All of them. That is where this is going. That is what we're building for. That is what our industry should seek to achieve. That is what we want to achieve. We want to change the world from a just trust us paper promises mess where people can change things up whenever the hell they want, to a cryptographically guaranteed system of math-based truth, where nobody can change anything unless it's been codified in an encrypted system. And that fundamental difference, in my opinion, will result in this transition. And this will be, in my opinion, one of the largest transitions in history of how the world works. And that's why I'm grateful to be working on it. That's why I work on this way. That's why I am into this. I am into this because there will be a point in history where people say there was before cryptographic truth and there was after. And before cryptographic truth, the world was a mess. And nothing was predictable and everything was failing every 10, 20 years. And there were booms and busts and economic crises every couple of decades. And after cryptographic truth, we entered a new age of productivity, emerging market growth, reliability, and simply just an ability for people to interact with each other in a predictable way. And that's why this will happen. That's why I believe in this. The value and the reason for this happening is fundamentally there. And I personally see it every single day in the users we work with. And after people experience cryptographic truth and use it as a user or use it as an institution or use it as a fintech, they don't want to go back. Doesn't make sense. They don't understand even the way that the other systems worked, because it's like it's just a joke to them once they experience what cryptographic truth actually offers. Once again, there's a virtuous cycle that we need to generate. We need to provide all the services. We need to provide all the decentralized systems. We need to provide all of the messaging protocols. We need to provide all the capabilities that are going to take the world into a state of cryptographic truth. That's what we do here. That's what we care about. That will likely result in an increase in the amount of services that are used and in the amount of services that we launch. So I don't even think this is the amount of services that Chainlink networks will run. I think this is a relatively small list. But I think this is the general dynamic, is that we have a virtuous cycle and a chicken and egg problem that we solve, where you couldn't build fraud-proof gaming in certain cases without fraud-proof randomness. And once you could, you had fraud-proof gaming. And then people came and played it. And then other people came and said, man, I want to make a fraud-proof game. Or you couldn't build DeFi without certain types of data. And now you have that data, and now you can build DeFi. And guess what? People really want DeFi because the paper promises of Robinhood or Wirecard or Enron or whoever are no longer their only choice. And so that is what we need to keep doing. We need to keep generating these services with our amazing community, our amazing partners, our amazing users, all of these people that we work with that we're just amazingly grateful to work with in enabling them and helping generate a world powered by cryptographic truth. So once again, I'm truly amazed at where we are in history. I think the ability to transition the world from a just trust us paper promises model to a cryptographic truth, mathematically guaranteed world is a once in a lifetime, probably once in a many lifetime opportunity. I'm personally deeply grateful every single day to be working on it. And I'm just amazingly impressed by a lot of the other people working on it with me. I'm also amazed that we finally have the technology thanks to Bitcoin and other subsequent advanced iterations like Ethereum and others to finally solve the problem of just trust us paper promises and replace those with cryptographic truths. So not only, is this a unique time in history, but we can actually solve this problem in the next few years. And I think that'll be looked on with real historical significance. That's my personal belief. I think it'll be looked on as something like the internet, because just like the internet, it'll completely reinvent how people work with each other, how the world works, how people interact with each other, whether they have or don't have certain things like bank accounts, insurance, any number of other things, for the reason that cryptographic truth was previously unavailable and it became available. Now, if this is interesting to you and you're interested in solving these types of problems, and you can see that cryptographic truth is the future of how the world will work, I encourage you to contact us. We work with people all over the world. We work with people in every country in the world. We want to work with you to make sure that your insight, your talent, your belief, your interest in generating cryptographic truth and making the world work in this way is something we can collaborate with you on. We have over 250 people right now at Chainlink Labs, some of the most amazing, most impressive people I've ever met in my life. And we're growing rapidly to help enable this together with many other teams in the Chainlink ecosystem. And I encourage you to join those teams or to join us and to really examine if changing the way the world works by making it run on cryptographic truth is something that you find interesting. And if that is an idea that you find interesting, and if you have a desire to work on that, whether you work in research or engineering or marketing or sales or operations, there are teams in our ecosystem that want to work with you that are growing rapidly due to the demand that the Chainlink system and networks are experiencing. And we want to hear from you, and we want to work with you in a very collaborative, fast-moving, impactful environment. Because I have to tell you, on a daily basis, we are now making this happen. So if you're thinking about, do I want to work in the blockchain industry? Where do I want to work in the blockchain industry? I think Chainlink Labs and the Chainlink ecosystem is a great place to make an impact across many different use cases and many different chains, and generally just generate a lot of change in how our industry works and how useful it is to society in general. So if you're interested in this, please contact us. Beyond that, I really do want to say that I am deeply, deeply grateful to all of the people working on the various Chainlink network systems and services, on CCIP, on our efforts to make sure that users get an ability to integrate with Chainlink properly. All the people that inform people about Chainlink in a correct way and make sure that people know the benefits of it. And our amazing and kind of very supportive community, as well as the larger cryptos community. I think new appreciation for the benefits and improvements we can bring to the crypto industry. I'm very grateful to be working with all of you, and I can't mention everybody by name in this talk because there's just too many people, and even all the categories or all the specific initiatives. But for whatever it's worth, I think it's important for everybody to know that I and many of the people that I work with are deeply, deeply grateful for the support of everybody that puts forward effort to make sure that our systems are secure, reliable, provided to important users, and that people are properly informed about what this actually does and how it can improve their systems. So once again, thank you very much to our amazing team at Chainlink Labs, all the teams in the Chainlink ecosystem, the larger Chainlink community, the amazing developers we're working on with on the protocol, and all of our amazing developers and users that give us regular feedback on how to improve. I'm once again deeply grateful to all of you. So thank you for listening to my general explanation here. I hope it's been useful for you, and I'm looking forward to seeing many of you in person and working with many of you on realizing this vision of a world powered by cryptographic truth. Thank you very much.